Similar figures and proportions are where we apply what you learned in Unit 3 of ratios and proportions to geometry. This is the connection between the two. First, similar figures, they are figures with the same shape, but they are a different size. And two key facts to know about similar figures. First, that their angles are congruent. These two triangles, triangle ABC and DEF, are similar. That single squiggle mark means similar. There are no equal bars because they're not equal, they're just similar. So if you look at their angles, 80 degrees, 80 degrees. They are congruent. 40 and 40, 60 and 60. Think about a wallet size picture and an 8 by 10 picture. It's just been enlarged. It still has the 90-degree angles. If you've worked with a picture in something like Microsoft Word or another computer program, when you go to enlarge it and you click that corner button and you drag it down, what you've probably noticed is if you don't drag diagonally, if you just went down or to the right, your picture becomes skewed. Either somebody's face gets really skinny or it gets really large. And that's because the original and the new picture are not similar. But if you drag from the diagonal, the measurements stay proportional. Another key characteristic is their sides are proportional, like what I was talking about with the wallet size picture and the 8 by 10 picture. If you look at their side lengths, the corresponding sides 4 and 12. These triangles are scaled by a factor of 3. Each dimension has been multiplied by 3. 3 times 4 is 12, 6 times 3 is 18, and 6 times 3 is 18. So those two triangles are similar. Determining if two triangles are similar. What you do is you have to make sure that their sides are proportional and also looking at their angles to make sure they are equal. So first let's look at our corresponding sides. Segment DE, that's the bottom here, it corresponds to RQ. Okay, EF, the left, corresponds to RS, and DF corresponds to SQ. So we set up ratios comparing those corresponding sides. I tried to color code them for you so that you could easily match them up and see where all this has fit in. The side length for DE is 7, RQ is 21, EF is 8, RS is 24, DF, the right side, is 12, SQ, the right side, is 36. Each of those ratios, if you simplify them down, are 1/3. So we can conclude that their corresponding sides are congruent, but if you remember from the previous board, that's just one of the characteristics. We also need to check to make sure that their angles are congruent. 34 and 34 are congruent, 106 and 106 are congruent, 40 and 40 are congruent. So we can say with confidence that these two triangles are similar. Make sure as you're taking your notes that you have both of these triangles written down with their measurements. Otherwise, this information is not going to make sense to you when you look back at your notes. So if you need to, pause the video to make sure you included everything that's on that board. For similar quadrilaterals, you do the same thing. These two are not similar. I can tell that by looking at them because their angles are not congruent. Quadrilateral ABCD has 90-degree angles. FGEH has, it's a parallelogram, so I could tell that this one is less than 90, this one is larger than 90 degrees. So you have an acute and an obtuse angle. So they are not similar even though their side measurements are the same. So keep that in mind. So let's check for these two rectangles. They both have 90-degree angles in their corners, so I just need to check see if their sides are proportional. So I'm going to line up corresponding sides, 50 over 45, and I'm going to see, I don't know, is that proportional to 80 over 72? I'm not having to put all four sides up there as ratios because they're congruent because it's rectangles. Here's a proportion. If you remember from Unit 3 of talking about proportions, they have equivalent cross products. If two ratios are proportional, you can cross multiply and get the same thing. So we're going to check that. 80 times 45 is 3,600. 50 times 72 is 3,600. So yes, those two things are equal. So yes, they are similar. This gives you another way to check. On the previous board, we simplified each of those ratios, and you could have done that here. Let's see, you would have gotten 10 over 9 as the simplified ratio, or you can cross multiply. Either way. So let's practice a little bit. Tell whether each of the figures are similar. Again, make sure you've copied the diagrams and then test it on your own, then check with what I've come up with. For practice A, if you were watching, you probably noticed that I figured that one out very quickly, because if you look at their angle measures, 40 and 34 are not congruent, nor are 70 and 73. So based on the angle measures alone, it's not similar. If you would have went and compared 18 over 48 and 12 over 28, you would have also seen that those were not proportional, but you don't even have to look at the sides if you know that the angles are not congruent. For practice B, the angle measures are congruent, so now we need to look at the side lengths. So I stacked the corresponding sides: 5 over 20, 7 over 28, 3.5 over 14, and 10 over 40. And if you simplify each of those ratios, you get 1 over 4. So for part B, those two quadrilaterals are similar.